Usually we talk about cross-border cooperation here in the carpet talks. This is more the focus, but already with the very nice project our Canadian colleagues are leading the big project. We already included a more global perspective, and actually it is interesting also to start with comparative approaches and learn a bit more how approaches towards cross-border cooperation may change, what the similarities are, what the changes are. But we have not yet arrived at the level of space. In Europe, we have a notion more the place-based approaches when it comes to territorial development. So that is extremely fascinating and interesting what you will present today. I'm sure that we will have a very interesting exchange between the space and the place, and what's the approach of politics maybe in between. Thank you very much. Welcome, and we are very excited to listen to you.
Well, thank you very much. Thanks also to all of you for sticking it out and after a long day still being here. I couldn't have asked for a better introduction into what I'm going to talk about and the importance of it. And I think we all recognize that food transcends all borders, right? Our food system is a global system. So if I cared only about monitoring food in France and the agricultural field in France, I, of course, would have major problems, because if, as we see, there's a war in Ukraine and two of the biggest food producers and exporters of the world are at war, that has implications globally. That has touched every single country in the world. So what I'm going to start to talk about today, I'll give a little bit of a background, and I'm curious how many of you recognize that NASA does food security and thinks about agriculture? All right. Good. We're in a good place already. And I think I'd like to start by saying that food security still remains one of the biggest challenges that we face in this century. How many of you have heard about the Sustainable Development Goals? Great, good. I taught a class on sustainable development, and there was very few hands that had heard about the SDGs. So you'll all be aware then that SDG 2 is zero hunger, is one of the major sustainable development goals. But actually, we're only getting further and further away from that goal. And if we look at the pandemic and we look at climate change, and as a consequence, an increase in extreme weather events, and that's compounded now with the war in Ukraine and in inflation, what we've seen is a tremendous impact, and we're seeing unprecedented food insecurity across the world. And if we look at acute food insecurity, right, there are a lot of different statistics about food security and the levels of it. If we think about acute food insecurity, right, you're on the verge of almost going into the famine state. In 2019, globally, the estimate was around 135 million people. We have more than twofold, so 2.5 times that in 2022, according to the World Food Program estimates, to 349 as a direct consequences of these causes, right? The 3 C's, if you want: conflict, climate change, and COVID. And we have 49 people on the verge of famine across the world. Okay, that is really critical. So space, and why are we here? And I think what we need still is a lot of innovation in developing methods that are robust, that are transparent, that are scalable, that help us to measure what is happening on the ground and across our agricultural systems across the world. And that's really important for being able to make a change, to make a difference, to measure. So if we just look at this last summer of 2022, we had a lot of disasters. We can talk about them in many different ways. If we look specifically at weather and heat waves, we had a massive heat wave across Europe. We all experienced it, we saw it. We are seeing the 5th consecutive drought in Eastern Africa, in large part due to La Nina. So that is having massive consequences as well. We had a drought in Northern Africa. We have another drought developing in Northern Africa at the moment. So a lot of different parts of the world have experienced a lot of extreme weather, and that's just thinking about this last summer. So space. Essentially what we've got is a lot of satellites monitoring the Earth, monitoring the air about the Earth all the time. And if you think about how these work, the Earth is rotating, and we've got these satellites in this orbit, and eventually what they're doing, they're taking images all the time. And as the Earth rotates, they can and eventually give us a complete picture of all the world's surface and every single field across the world all the time. And here I'm just showing you NASA's constellation of satellites. They're observing what we can see in the visible range, right? Like that's what we see, the red, blue, green. but they can also see across the electromagnetic spectrum. So we can see in the shortwave infrared, we can see in the thermal. And what that means is we can see through satellites a lot of things that our eyes can't see. And these things become really good indicators for looking at structure. What do crops look like? For looking at the health of crops. For looking at absorption of crops of water, right? That's a really good indicator for us of the vigor of the crop, the health of the crop. So while they can see what we see, they see actually a lot beyond what we can see. And imagine that we have this kind of data across the world every single day on the entire land surface. That becomes really important. And so this is, for example, what the world looked like yesterday from a NASA satellite called VEERS, and it gets 2 looks a day across the world. And we are also now moving into getting, so when we think about satellite data, right, we've got different resolutions. I won't go into the details of all of this, but it means you can basically what we can resolve on the ground. And so we're now getting to the point where we actually have data that we can differentiate at the field scale and at very small field scales on a near daily basis. And a really important thing that's happened in the space agencies is making these data free and open as much as you can. And NASA really led the way on that. The Copernicus service in Europe followed suit. And this has made a massive difference because if before that, the plan was you had to pay for data. And so the minute you make data free and open, you can utilize it and advance the use and uptake of this a lot more. The other thing that's really important that you alluded to earlier was the long term, right? So this gives us a way to monitor the world on a daily basis, what's happening from today to tomorrow to changes. But what's really important for satellite data is also the long-term data record that it provides us. And actually, for in large part, a lot of the satellites and the main kind of early on satellites came on in the late 60s, early 70s. The Landsat series is from NASA. That gives us a 50-year record of the land surface, right? And so that means not only can we look at what's happening right now, what's really important is to look at change. How has deforestation changed? How has urbanization changed? How have different policies from different countries, right? You're thinking a lot about borders. How has that impacted land use, land cover change? And so it's really important for us not only to have these satellites looking at now, but also having this long-term perspective. And so just to give you a few examples, this is looking at Pakistan. We all heard about the devastating floods that happened in August 2022. And this is the kind of thing satellite data can see. This is actually looking at very high resolution satellite data. And you can see very quickly, when you have to get quick information, you can see the impact of those floods. And you can see, for example, all the agricultural land that was destroyed and lost because of these floods, and of course, many other things. And so we look at certain things from a very close perspective at high resolution, but this is zooming out and we can actually look at the entire flooding plain. And so this was before the flood, and that's the expansion of those floods after, and start to look at, well, what was the impact? How much area did it impact? What land covers did it impact? What cities? There's a lot of work also, of course, in the disasters community that uses these kind of data to inform very rapid. And there's a center here at University of Strasbourg, many of you have probably heard of it, called CERTIT, that does a lot of this kind of work as well to inform humanitarian. So what I'm representing here is a program called NASA Harvest. This is NASA's food security and agriculture program. We sit inside of its applied sciences program. And the goal really of this is to run the transition between research into operation, right? Our goal is to make sure that these data are not just staying in the research domain, but are being transitioned into applications that really make an impact. And being able to help and make sure that these investments in these satellite data systems are actually being taken up across the agricultural sector and across the world, both working with the private sector as well as working with governments. So I'll give you a few kind of more global examples, and then I'm going to go into detail on work we're currently doing with the Ministry of Agriculture in Ukraine. But to give some examples, this is the global cropland extent, and it's a study that's going through time between 2000 and 2019. And what it was looking at is the expansion or contraction, right? How are croplands overall across the world changing? And where is it changing? And where is it changing the fastest? And at the expense of what other land covers, right? We know that oftentimes we've seen a lot of deforestation that then gets converted into pasture lands, and then that gets converted into croplands. And what this study found is that the most notable expansion of croplands has been actually in Africa, also in South America, and it's really replacing a lot of natural vegetation and tree cover. And this, of course, is in conflict directly with a lot of our other sustainability goals about protecting our terrestrial ecosystems. At the same time, we have a tension, right? Global population is growing. Populations and economies are often, we have a lot more demand for meat. And if you think about how much calories and how much croplands you need to feed one cow to feed you versus if we were directly consuming that wheat, right, that's a big difference. And so when we see a much higher demand, and we've seen especially coming out of China as that economy strengthens, and in India, that puts a lot of pressure on the global croplands. And where is that going to come from, right? So that's a big challenge we have to address. And there are different estimates as to how much more food we need to be able to produce in order to feed the growing population by 2050, for example. And they're anywhere between 30 and 50% that we need to produce more food in order to feed our population. So satellite data can not only help us look at, well, where are the croplands? They can also help us look at where are the specific crop types being grown, right? Where's wheat versus corn versus rice? And you'd think we had a good sense of this, and we don't. Okay, we have a general sense of this, but we need a lot more information, and that changes every year in response to policies, in response to demands. And so this is a really critical area of work also in satellite data, and the basis for a lot of analysis that comes on top. So one of the things we do under a G20 initiative is called the Crop Monitor. And here, our end users are policymakers, recognizing that the global system is a global system, right? So it's not enough for me, as I said before, to know just what's happening in France. It's actually, I need to know what's happening globally. And it's not enough for me to know just what's happening in the biggest production exporting countries. I also need to know what's happening in those countries most vulnerable already to food insecurity. And so what we tried to develop, this is based on satellite data and other information in collaboration with all the G20 countries and a lot of the humanitarian organizations, so the World Food Program, USAID from the US side, JRC from the European Commission side. And we release these once a month. This just came out today. So this is what global crop conditions look like at the moment. And we kind of tried to develop this very simply, because understanding that even though what's behind it is very complex, we know that nobody's going to use this if we're presenting very complex information. And so here what you're looking at is anywhere that you have color or croplands, anywhere that's a dark gray is area that are out of season, right? They're not growing right now. And then anywhere that's green means things are about average. Okay, they're a bit, close to normal. Anything that's yellow means we better be watching this area a little bit more carefully. And red means, okay, we already know it's past the point of recovery for that particular crop. And we'll give you a quick icon of which crop is being impacted. And so, for example, here we see in Brazil and Argentina, we have a drought. We have some dry conditions, and it's impacting corn and soybeans and wheat. We know in the US right now, a really important wheat area in the Central Plains, there's some dry conditions. It's still pretty early in the season, right? So if we got rains in, that could recover. But we can also see that in Russia and Ukraine, two major producers. In Ukraine, of course, there's a lot other going on. There's some dry conditions developing. Eastern Africa and the Horn of Africa is still seeing a lot of drought developing in Northern Africa, right? So it gives you a sense of the global food system, what's happening at the moment. And these get published in different bulletins that we put out every month and are used a lot for informing policies and decisions, and are often picked up by a lot of different governments and agencies. What we can then do is kind of try to transition these capacities into national governments as well that are trying to monitor their own information. And here again, I'm showing some examples. We were doing a lot of work in particular in sub-Saharan Africa in trying to build up their capacity for being able to monitor their own agricultural system. And as you've been talking a lot, we know that food security also equals national security, right? And we know that there are a lot of concerns if you have, for example, droughts, that can trigger large migration, right? And so it is really important to be able to have a handle of this and to have an understanding of what's happening in different parts of the world and what could be driving a lot of other things than just food security. If you recall the 2008, for example, uprisings and that had in the Middle East, we know that there were a lot of factors, but one of them was food prices and food insecurity. Maybe I'll skip this, but I'll just say that it's not enough to produce good data. It's not enough to be a good scientist and put a good map out there from our side, right? If you're not working with whoever needs to be able to use this data, your data is not going to have an impact, okay? And so it's really important, this concept of co-development and making sure that whatever you're doing with the data is being led by somebody who needs it. Because I'm showing you a lot of good examples, but I could equally say, you know, I could show you a lot of examples of data that's not validated, not verified, and coming to different policy recommendations or conclusions, right? So this is very important to keep in mind always of who's my user for this, and are they connected, and are they part of the development? And so just to give you one example where we worked in Uganda with their Office of the Prime Minister, where they developed their own system using satellite data to be able to trigger their own disaster relief finance program. And in particular, there's a region in Uganda called Karamoja in the northeast that's very prone to droughts. And what they were able to do is to trigger their disaster relief financing, right? So they could see there's going to be crop failure. And what they did is they released in a financing program so that they know, so that farmers and other people that are going to be impacted, they're being preemptive, rather than then having to deal with what would happen if there was a drought and complete loss. And they've actually been able to save over the years of this program already $11 million in food aid. And otherwise it would have been much, much more costly for them to be able to use. So one last, I think, example before I go directly into Ukraine. Again, talking about borders and information, and how do we provide information that is standardized, right? So a lot of the value of satellite data is we can implement the same approach in Brazil, in Mexico, in Bolivia, in Peru, and have that directly be comparable. And that's also very important. And so here is, again, a study looking at deforestation in South America at a continental scale, looking from 1985 to 2018. And the color coding here, hopefully you can see it, is by year. So we can see which years were there higher deforestation, where was it getting deforested. We know from policies in Brazil, there was a lot of progress before the previous government, and then we could see the implications of those different policies on deforestation and coming back into more deforestation. The government uses this kind of information to trigger, and they're coming back again into this program. When they see areas being deforested, they can immediately go and start to deal with that. But anyways, just here showing the rates of deforestation, which are absolutely massive in South America, and of course this has a lot of consequences for sustainability. And I'll skip through that. Okay, so then going into now the conflict in Russia and Ukraine. And so we've actually had we've worked on Ukraine for a long time prior to the war, because it's such an important agricultural country. And when the war started, their Ministry of Agriculture came to us and said, hey, can you help us look at what's happening on the ground? Because satellite data is really the only way to be able to monitor a lot of those areas that are under direct war and conflict, especially in eastern and southern parts of Ukraine. And so why do we care about Ukraine? I think we're all probably well aware that Ukraine is a really important producer and exporter, right? So it's very important for its own economy and very important for the world in general. World Food Program, just the World Food Program before the war, sourced about 40 to 50% of its wheat from Ukraine directly. Okay, so very much important. There are a lot of countries that are strongly dependent on exports from Ukraine. So wheat is bread for a lot of countries, right? And so if we look at Moldova, Lebanon, for example, before the war, 80% of their wheat was coming from Ukraine. So this was a request from the ministry, and I'll skip over this, but mainly what they said is, can you monitor in particular the conflict areas, the areas that are under Russian occupation? And I'll skip this to just show. So the first thing we did, and this was back in April, so a little bit after the war started, the first thing we tried to do is assess how much of Ukraine's cropland were under Russian occupation. And then also trying to understand how much of their winter crops, so their winter crops are primarily wheat, versus, and the wheat was planted. So I think a lot of you probably know, wheat is planted in the fall, right? So if you look around here, a lot of the fields that are now green are wheat fields. So they were planted before the war, but a big question was going to be, how much of that wheat would Ukraine be able to harvest? And the second question was, how much of the spring crops, right? So that's the corn or the maize, sunflower, would be able to be planted, because those are planted in the spring. And so the first thing we come up with this, we have a partnership with the Institute for the Study of War. They give every day an update of where the front line is. You can see here the previously occupied areas from 2014, those are in purple. versus the red is where the currently or the newly occupied areas were. And what we found was about 23% of Ukraine's total croplands were under Russian occupation, and around 28% of the wheat of Ukraine was under occupation. So those are very significant quantities of their agricultural production under occupation. And this ended up on just about every news headline around the world. These were the statistics that then the UN was using, because what everybody was doing until then, there were no statistics to be able to produce these numbers. Generally, the statistics people did have was at the oblast scale, right? So that's kind of the administrative level unit where statistics can be made. But we know that the occupation doesn't follow any administrative boundaries. And so the only way to really be able to estimate this was being able to monitor every single field and aggregate those to be able to come up with these statistics. So once we did that in April, we could start to continue to monitor what else was growing and how could we monitor what's happening. And so another major crop in Ukraine is rapeseed. A lot of that's grown here too. It flowers like this, right? It's a beautiful yellow. It's the color on the Ukrainian flag. And what you see on the top is the satellite imagery, and that's that bright green. So we could see that. And as soon as we can see that signal, we could classify all of those fields. And in fact, that's what we did. So we can pick all those up. Now here, just to give you context, we're looking at 3-meter data. Okay, so we're looking at 3-meter data across all of Ukraine, and we're able to classify every single field to be able to monitor what's happening. We can then, what we did is we delineated every boundary of every field in Ukraine. Okay, again, at this 3-meter resolution. And ultimately, we could create maps that look like this, but across the whole country, mapping the different crop types and continuing to classify these as the season was progressing. And so one of the big questions again was this class: what was not going to be able to be planted? And there were a lot of different assumptions by different governments. A lot of kind of all over the news was this big hysteria. We were going to lose so much production coming out of Ukraine because 30%, 50% of their fields would not be able to be harvested. And so we said, well, let's figure out what is that percentage that's not harvested. And so we started to look at different kinds of data sets to be able to monitor this on an ongoing basis. And so here, this is Kherson Oblast in the south of Ukraine. The green fields, remember, are those fields we already said these were planted to winter crops. And the red is us looking at that progression of planting, okay? So we can see them as they're planting, and they're planting almost everything. And we thought, gosh, that can't be right. That's not what everybody's saying. And we do this for the entire country. And what we find is, no, they're planting almost everything that they can. So here again is that whole map of Ukraine. Everywhere where you see these speckled browns, and I give you kind of a zoom in there to just give you a sense of at what resolution are we seeing this, they planted almost everything. The red, again, is that occupation line. And so unsurprisingly, we see a concentration that wasn't planted in the occupied territories. But even there, about 10 or 11% were left unplanted. So it's not that 30 or 50% that everybody was talking about, including the ministry. The ministry didn't believe us, okay? So I should say. And we were doubting ourselves too, because we're not on the ground. We're not there. We're just looking at satellite data. But we are validating to the best of our capabilities. Remember, we have 3-meter data every week to every 2 weeks. So we can look at the fields at a very fine resolution. And that's what we did. And what we find is when we looked at the distance between the number of fields that were not planted to the front line, unsurprisingly, this is a front line. Okay, going this way is going towards Russia. This way is going towards unoccupied Ukraine. And we see that the large concentration of unplanted fields are along the front line. And as you get further away from the front line, also going in this direction, right, towards Russia, they're planting almost everything. Okay, so then we continue. Now we are getting into the summer winter crops, and we're able to separate out another major crop, sunflower. I don't know how many of you use sunflower oil for cooking, but you might remember once the war started, it was really hard to get it and it was really expensive, right? That's why Ukraine exports around 45–50% of the sunflower to the world. And they plant a lot of it. So now this kind of color here is showing you all the sunflower fields. And something weird pops out to us when we zoom out for 2022. And what is it? The same thing that we keep seeing over and over again. Just around the front line, we see this kind of blank area, but everywhere else it's planted. And just to make sure, we also map 2021, and we see a very similar pattern to what's planted, but it goes all the way up to the front line here, right? So, and so we end up having, this is what our map looks like. Again, 3-meter resolution of the different crops. We do get to validate our map because we have a partnership with a university in Ukraine. They did a field campaign during the summer, only in the non-occupied territories, right? So we can validate this part of the map, and we're about 94% accuracy. Okay, so we're doing pretty well actually at what we're able to do. And that gives us confidence in what we're mapping in the occupied territories where we don't have any ground data. But we have kind of this discrepancy between us and basically the rest of the world. So it's not just the Ukrainian government, it's the USDA, that's the US Department of Agriculture, it's the UN FAO, it's the World Food Program, it's International Grain Council, all these big organizations, but that's their job to put out these kinds of statistics. And so we can update these statistics again about what's under Russian occupation and what's not. About 77% of, or 23% of total croplands are occupied, 21% of summer crops, so that's your corn and your sunflower, 29% of wheat, 14% of rapeseed. And one thing we can do to, again, build confidence is to compare to the Ukrainian statistics of planted area of winter crops, because that was planted before the war and they had good numbers. And our statistics agree really well, okay? So again, we're finding whatever we can to make sure, because we recognize that the stakes are really high in what we're doing. And again, that goes back to what I said before. Anybody can produce a map, or a lot of people can produce a map, but the trick is not to produce the map. The trick is to make sure that you're getting correct information, because otherwise you're doing a disservice. It's not only that you're not helping, you're actually causing problems. Okay, so the next question, remember, is, well, how much is going to be harvested? Again, 30 to 50% is not going to be harvested, okay? That's the headlines everywhere. And we find a different result. And again, the ministry is like, there's no way. We talk to, this guy here and that guy there, and they're saying nothing's being harvested. And so I think, okay, well, how do we show them that what we're doing makes sense? And so I'm going to take you through this too. This is what just one field looks like, okay? And this is in Kherson, in an occupied territory. This is a field of a winter crop. This is in March, when it's just coming out of winter dormancy. It's right now, so it's really, really short and looks like really short grass. Then it gets much brighter. This is around the peak when it's got a lot of vegetation. This is when it's senescing. Everybody know what senescing is? It's when the crop is drying out. It's becoming brown and it's drying, ready to be harvested. And this is harvest, okay? And so what you see here, this yellow, is what's left, the residue after it's harvested. Okay, that's what it looks like until the soil is tilled again. Oops. And so we see eventually the whole field is harvested, right? We see the progression, and then we see it start to get tilled. So that's when they're preparing the field again for the next season. And we can see this just visually, right? Forget our classification, our machine learning models and everything to do this. And what we see here, again, everything that's bright now, so the main winter crop areas are the south and the east. All these kind of light brown are the harvested crops. And the area where you see a dark patch is along the front line. That's where they're not harvesting. And zoom into just that part of the front line, okay, you can see this darker area. That's where it's not getting harvested. Everything else is. And so we can develop a model to capture this through time. We can map all the fields that are harvested. And what we find is around 88% of the fields in the occupied territories are harvested, and around 96% are harvested in free Ukraine. And we do a validation. So again, we don't just make a map. We then go and do a random sample, and I won't get into all the statistics. And what we find here is a field that it's actually very hard to see from where you are, but it's been bombed. Okay, so this field, we can see the bombshells in here. And that field still gets harvested. So they're taking actually a lot of risks. And I'm not saying this is happening on all the fields that are shelled, but some of them are, and they're still being harvested. And so what we find is around 9% of the wheat fields, actually 88% of the wheat fields in the occupied territories were harvested, much higher than everybody was saying and was expected. And it kind of makes sense. Farmers farm. That's what they do. They have the land, and that's what they're going to do. They still need to make a living. We don't know who's harvesting, who's farming. There's a lot of different research that came in and said, Russian farmers took over, and we can't validate that, right? We are looking from the satellite. We can't say who's harvesting, but we can say it's getting harvested. And to make a long story short, I won't take you through all the statistics, but our production estimate, right? How much ultimately gets produced in Ukraine is 26.8 million tons, okay, almost 27, whereas everybody else's statistics are around 2021, so it's 6 million tons more. That is significant. That is very, very significant. And if we look at how much that costs, that's a loss of over $1 billion just from the harvested wheat that doesn't revenue go into to Ukraine, okay? And independently, Bloomberg and others have done a lot of other research around what's happening to essentially stolen grain. And what a lot of research found, there are a lot of ships with wheat going out of Ukraine, going what's called going dark in the Black Sea. Then that grain gets transferred over into a Russian ship, and then it goes out and gets registered in Turkey as official Russian grain. And so I can't verify that. That's not our work. Our work is just to say how much was harvested, how much was produced. But there is a lot of evidence coming out that there is a lot that could be talked about for that 6 million missing tons. And so, again, this got picked up everywhere, including by Bloomberg and other news articles. And in the end, the ministry is using these numbers at the moment. And a lot of the major organizations have also revised their numbers up based on this information. I'll maybe just very quickly say we're also using satellite data to monitor the damage to fields. So far, we've mapped around 4 million shells or bombs inside of fields and being able to monitor the damage and the destruction. And a final thing, I think we also have heard a lot about our fires, and we've seen a lot of those news articles and everything. And again, it's the same story. These are the fires that we see in agricultural lands, and you could basically draw the front line without knowing where it was based on this kind of information. And so one of the things that this has triggered for us is to develop a rapid response center on agriculture for supporting and informing policies, because there's a lot of need and a big gap where remote sensing data can help to fill that gap. On Ukraine specifically, we have a letter from the ministry asking us to continue this work, and they're actually coming here at the end of March to do a training with us and to try to help them continue to monitor and provide information that is transparent. And so I'll just conclude and say that we're at a critical point for food security globally, and our food system is interconnected, is interlinked. Of course, decisions by different countries and policies can have massive implications and influences. We're going into a time with a lot less transparency, unfortunately, a lot more uncertainty, both in terms of the climate and the weather, and also in terms of politics and world powers. And satellite data can be a really important tool, but just as much as important is this collaboration and coordination across agencies, across borders, across the world, in order to help to really make a difference in these kinds of global problems. And with that, I'll...
Thank you very much. This was really very, very impressive, and I think we're all impressed by the detailness of your data. And I mean, it's always a question of how to use data, and this is what I found very interesting. So you can use it in two perspectives, responding to a concrete threat. And this is exactly a very good example that you gave us with the Ukraine war. What I was wondering about is more this long-term perspective. Are you also doing simulations? Because coming back to the more broader picture of the world, I would be interested in the question of how are there any simulations and how are they used? Who is using these data when it comes to climate change? So I don't want to immediately leave the Ukraine's exact questions, or we could stay with the Ukraine, but I would definitely like to ask as a second step, maybe the broader picture of what we actually can then use in terms of data, and who uses them.
Yeah, I mean, there's a lot of work on the simulations and on the models and trying to integrate more and more climate scenarios, right? And trying to understand risk to different countries, different parts of the world, and what those look like. One of the projects we're starting to work on now is, looking at those maps that we put out every month and looking at those areas that we have highlighted as yellow and red, and talking about under the scenario that some of those or all of those end up leading to a shortfall, what are the implications of that? And so what we're working now is with both USDA and IFPRI and other institutions that are more focused on the economics and trade and modeling to feed this data into their models and looking at food supply and supply chains and potential disruptions into that. So that's a very good question. There's a lot of work in that space in terms of, more building scenarios than predictions necessarily, right? So you're looking at different kinds of scenarios and what could happen and different probabilities around those.
I mean, there was a concrete reaction now from the world towards these findings.
Yep.
That led finally to a clear response that we need not to stop the change of the commerce. But in the long-term perspective, how would you evaluate when you have a lot of experience regarding this long-term climate change projections? How would you evaluate the effectiveness of international or global cooperation? Because we all talk about our detailed consequences. I come back to my place-based approach. In France, for 3 weeks now, we have a very dry season, and growers in the south of France are already thinking about how the harvest will be. Probably there will be no harvest at all when it comes to fruit planting.
Right.
So that's the question: individual reaction versus a more global approach.
Yeah, you're asking more about the cooperation of what you do with this data, or more? I mean, I think there are a few different things. One is a lot of the warming scenarios are very much on warming in general. And I think what's really important for agriculture is, when does this particular extreme event happen? So it's true that overall warming is very important, but it's also true that if I have, what we're seeing is also an increase in frequency and severity of extreme events. And so if I have a drought right at the critical part of the growing season, when the crop can't recover, that will destroy the entire season. That's much harder. What we know is we can forecast there's going to be more of that under the different scenarios, but that's a lot of work also on the climate modeling side, is how do you essentially translate those scenarios into weather and into kind of extreme events, and when and where they're going to happen. Because if I have the drought earlier in the season, I can still recover. But I think there is a lot of recognition, not enough, that we need to be dealing with this more. And I think, looking at the COP27 and the new fund for loss, especially for the most vulnerable countries, is maybe a start of a step towards some of that recognition. But of course, in this climate, I think we need even more to have international collaboration and cooperation, because this influences everybody.
Okay, maybe before we open up, I take the advantage of being a co-moderator to ask 3 questions. One is about this free data available. I mean, how come it's so free? And are there also not temptations to limit this? Because, with the internet, sometimes it's being done by governments. Would there be an incentive maybe for Russia to try and, obstruct information that you can get on? Is it possible? I don't know. I've not the technical knowledge, but it's very interesting. And then the second question is, if you're providing such accurate data, why do the governments not listen to you more than and earlier? Why do they, before they give out this false information, apparently? And the third question is about whether you're working on food security, but are these data sets used by NASA also for other topics? I don't know. I've been thinking about the earthquakes or other public policy topics.
Yeah. So good questions. I'm going to have to. Okay. So the first one's on free data. For a long time, it wasn't free at all. And the use and the uptake of it, I mean, I think there's some charts I don't have in here that show just how much more of this data is used. This is taxpayer money. So I'm not talking about commercial satellites. I'm talking about taxpayer money that goes into launching these satellites. It should be free and open, and that's how you get the value for it. And unfortunately, we're at a time where that temptation might be coming back to Europe, because I've just heard there's some talk about Sentinel-3 perhaps starting to be a pay-for service. And that is just a terrible, terrible, terrible idea. And that's already been proven to not be because people don't have access to data, they're not going to use it. And you lose the value of having put those billions of dollars up to going and putting these systems in place. The second question was about statistics.
Yeah.
Sure. I mean, Ukraine was very specific.
Why do they not believe you, the government?
We don't always put out, USDA generally does a very good job. Each country does a very good job at their own statistics. A lot of our goal is to help build up that capacity and capability within countries. We're not in the business of telling other countries what their production is, but rather we try to help build their capability to use the satellite data so that they have confidence in their own statistics. So Ukraine is a specific case where they came to us and said, can you run these? We do, of course, we still develop models and run them all the time on yield statistics, and a lot of that gets translated into those qualitative crop condition maps that I showed. But we do try to work with different countries. And I think this year, now that we proved that we probably were correct, there'll probably be more uptake of what we come out earlier. So there was just, all the other information was actually saying we were wrong. And so there was a good reason to first kind of see what, not necessarily, I mean, we ourselves wanted, the amount of verification we did was tremendous to make sure we were correct.
And the other fields that are...
Oh, right. So yeah, of course. I mean, NASA, so just on its applied sciences has a field on water and on carbon and on greenhouse gases and on disasters. And so it has a very wide range of applications. And so we're the food and agriculture part of it. Absolutely.
Okay, so I think we can open up. Valeria was...
Yeah, I was curious about, you had a slide on agreements with African countries, and I wanted to know more about that. Is it a kind of an agreement like in the case of Ukraine, where you have really done work for those countries, and why those countries in particular? I think I only remember Kenya, Uganda, and Tanzania. So I would like to understand more about that.
Sure. Each case is different in terms of the request is always coming from the country. And in terms of the crop monitor, it was initially, we started it with the Ministry of Agriculture in Tanzania, where they said, okay, we could really use this kind of capability, and we work with them, and we still work with them to help them produce this bulletin every month. But the best way to grow what you're doing is not for me to say, hey, look at this, this is really useful, but it's for the government of Tanzania to say, this is really useful. And they've now, have an operational budget in the ministry's budget to do these. And so then next came Kenya and said, hey, can you help us do this? And other countries have come forward and asked. And so the more you can demonstrate that what you do actually has impact and value, the more there are requests for being able to.
Is it just in 3 countries?
We're working with a lot of different countries on different projects and on different aspects. It's not just those countries that we're working with. Those countries that I showed are the ones that are developing in different stages of developing of a crop monitor bulletin. So that was just one example of the kinds of work that we do.
From the data that you've collected, do you have the data about the soil fertility? And can we use it in order to determine which type of food we could grow in each region or state, for example, to planify its agriculture? Can we do this?
There are different data sets of different indicators of soil fertility. And there's a lot of work basically on looking at where can crops be, what is the most suitable locations for different crops to be grown. There's a lot of work on different varieties. And as you develop new varieties, where are the best places to implement those varieties? Also, there's work on climate change and different scenarios and which crops, so for example, if warming is happening higher up, then winter, then a lot of the areas that grow spring wheat today would probably be more suitable or could become suitable for winter wheat varieties. So there is a lot of work in the remote sensing domain, but with other expertise and domains as well for that kind of work.
You have explained, and I think it's also very important, the importance of open data when you're collected based at least on public funds. And I think it's the same trend we have the data governance law at the level of the European Union. My question is, with that type of data and with the kind of thing we can obtain by artificial intelligence, how do you, or what do you do against the risk of a sort of general surveillance, because it's very precise and you can see many other things through this kind of data? So what kind of guarantee is offered?
Yeah, so I should specifically say that on the Ukraine case, we share the results and the statistics. We don't share any of those maps because that's very sensitive information and data. Yeah. So that's our agreement with the ministry, and we have made kind of maps of that, but the actual data we don't share. So we do have, of course, different rules in terms of and of what is sensitive, what isn't. The specific data we use in Ukraine at 3 meters is actually commercial data. It's not NASA data. It's a company called Planet. They get that question often when you get down to that resolution, and they have their own committee that tries to verify who's using the data and for what kinds of purposes. But I think it's a much broader question. We often get asked that by farmers who are very creeped out by why is NASA monitoring my fields? And you can see that I'm growing corn versus soy versus anything else. And the point is that transparency in data also helps farmers, right? So it helps to put more programs into place and help to understand what helps, what doesn't help. The data is there, and it's better to be transparent and to have, I guess part of the idea, if you have data, there's going to be more good than harm that's being created from that kind of data. Of course, anybody, there are nefarious uses of data, but I think the overwhelming benefit of having open data outweighs that by a lot, because whatever nefarious uses you're going to have for it, there's a lot more good because everybody has access to it as well.
Because,
But it's a very good question and one that gets debated a lot.
yeah, because in the satellites that you have described on your slides, some of them are purely private. So they can collect data, but they do not have any obligation to be transparent because it's sort of, private collection of public data. So how do we avoid
those
sort of,
Those are probably better questions for kind of regulators in this, because there are rules, right? What resolution is military resolution versus not, and that has changed. So I can say in the public domain today, in the commercial space, right, you can buy it, but you can get down to 30-centimeter data. There are certain countries that data is not available over, that you can't buy it. But that is today in the public domain, and that's regulated by international laws and government laws. So I don't have a good answer for where and how that boundaries gets drawn. But it probably obviously means that if you can get that in the public domain on the kind of military side, there's much finer resolution. So of course, Russia has its own satellites, South Korea has its satellites, right? So different countries have satellites that they put up, but that makes it even more important to have free and open data so everybody has access, right? And not just those countries.
It's different. I mean, if you have an open data, have you an open data on China?
Sure. I mean, the satellites are over the whole world.
Yeah, but is it open?
Does China provide their data openly?
I mean,
Yeah. So NASA data you can get for China, India, South Korea, any country in the world you want, of course. Yeah, absolutely. Yeah, absolutely. Same with the European data, of course. Yeah.
Not Ukraine.
Ukraine too. What I showed is sorry. So
I'm getting very confused.
okay. I'll try it.
Maybe can I say what I'm confused about?
Yeah.
Because first, at a certain point, you said it was commercial information on the crops in Ukraine.
Okay.
And first I thought you were working for who is you?
NASA.
NASA. So does NASA have an agreement with the Ukrainian government, but then it doesn't give the Ukrainian government the exact data? Because
it does.
If it doesn't give.
Okay, let me start again.
Okay,
let me start again. We have a partnership directly with the government of Ukraine.
You work for NASA.
I work for NASA. Okay.
But you work in Strasbourg.
Yes, we can talk about that in another. Yeah. So I can. Okay. Let me step 5 steps back.
Yeah.
So NASA tried to have a lot more impact in their applied sciences program, and they recognized that the way to do that, or it was an experiment for them. NASA Harvest is today is no longer an experiment, but it started as an experiment to be a government NASA program run outside of NASA. Why? Because that means that we can partner with governments without going through the government bureaucracy. We can partner with private sector without going through government bureaucracy. So my home base is University of Maryland. They competed this program as a consortium. We won it. I report directly into NASA headquarters. And if you go on the NASA website and you look at the Applied Sciences Agriculture Program, that's us, right? So we are part of NASA, but it's by NASA. Yeah, but not just finance. Like I report, the government, whatever NASA website will advertise us as a NASA program. Okay, but we're set up in such a way that we can have an impact without having a lot of the bureaucracy.
We're a private company or foundation, something like that.
We're not a private company. No. We are a NASA program. We just yeah. We're a university. Yes. But this is So that's what NASA harvested. Now, when we go back to there are two things, right? There's the data, the satellite data itself, and then there are the products you make from the data. Okay, so the data you get from NASA or from any other space agency is just going to be the wavelengths in different bands of the electromagnetic spectrum. You need to then analyze that data and to produce it into information. So you can download that data. That's not going to give you what I just showed you. So what I showed you is a lot of modeling on top of that data to come up with these products that I just showed you. Now, there are a lot of different kinds of satellites. All of NASA's data is free and open, and that's across the world. That's the whole world. All of the European Space Agency data is free and open across the whole world. Those data are generally a bit coarser resolution, okay? So NASA data goes up to 30 meter per pixel. European Space Agency goes into 10 meter. And the data we worked on in Ukraine is 3 meter. Once you get to that kind of below 10 meter, most of it is commercial data, okay? And that particularly what we used in Ukraine is a satellite company called Planet. NASA has an agreement with them. They shared all that data with us for free. Why? Because it was for a humanitarian purpose to help the government of Ukraine. Now, what I said we don't share is those derived products. So those crop type maps, for example, we have shared them only with the government of Ukraine because it's sensitive information. So if that data all of a sudden went to Russia, they have information about Ukraine that Ukraine doesn't want them to have. Does that make sense?
But you gave it to the Ukrainian government.
Of course, yes.
Okay, but at a certain point, I understood that you hadn't given it.
No, we're working very closely with them. They're coming here and at the end of the
Just that the general media, as I understood, was speculating about the negative effect.
Yes.
You wrote in the evidence
That's
that
right.
allowed for a more rational reflection on how to.
Yes, yeah.
There was another question back there. Yes.
Yes, I just had a comment. If you could expand on the commercialization aspect. I know you just said you had an agreement with Planet
Mhm.
and how they provided the data to humanitarians.
Yep.
Do you foresee any expansion either with other NASA programs or with the agriculture department on capitalizing on this high temporal and resolution in general?
Yeah, I mean, so you bring up a good point. Why did we go to the Planet data? I didn't go into all these details, they're more technical, is because Ukraine is very cloudy. And the Planet data, we didn't need to go down to 3 meter resolution data. The fields are very big, but there was a lot of cloud. And the fact that we had daily data meant that even if there was one day with the one area that didn't have a cloud in it, it meant we could get a look at it. And that's why that was the value of the Planet data for us. That opened our eyes and Planet's eyes to the use of their data. Previously, we only used their data for monitoring very smallholder systems, very small fields where we needed to get down to that resolution. And so as a consequence of that, we actually have a new partnership with Planet looking at agricultural assessments where they would provide data for a very low cost and different governments can make a request in to have different analyses done with that kind of data and resolution. So I don't know if that answered your question. Yeah. But we're not a commercial, so I should just say we're a government we make no profits.
The last question from there, yes.
Do you know if financial institutions are using your data in order to predict the rentability of the crops in order to
Sure. I mean,
build the assets?
there are a lot of big holding companies. So I remember once visiting Cargill in their offices in Ukraine, actually, and all of a sudden they pulled up one of our systems that we had developed for USDA. So we make a lot of our systems and our data free and open so that they can be and used by everybody. They have a lot of their own analysts and a lot of these kinds of companies. There are a lot of private sector companies that their whole motto is, we can do better than the USDA forecast and we're going to sell you our forecasts. So there's a very big private industry based on satellite data. Yeah.
Okay, well, that was very interesting and a new perspective on border.